really the lesson for today is the only one that has a lot to do with some of the geometry we've been talking about before. The remainder of the unit, you're not going to have to do so much with our geometry, like finding area and things like that. It'll be more focused on just the probability and statistics between certain events happening. But today we are talking geometric probability. Our definition of geometric probability is the area of some desired region out of some total area. So what I mean by that is maybe you have some large rectangle here. Let's say that its dimensions are 4 by 10. And within that rectangle, there's a smaller rectangle. And this one's shaded. And this one has dimensions of 1 by 3. So maybe they ask you, what is the probability of you throwing a ball at this target and hitting the shaded region? So the amount or the probability of hitting that shaded region is out of the entire target, right? Okay, and you could hit anywhere within that box and hit the shaded region. So we need to know how much does the shaded part take up out of the entire target so that we can come up with our probability. So if we're trying to figure out how much space is taken up by some rectangle, we're finding its area, right? So first we would need to find the area of the shaded region. So our shaded region is a rectangle, so what am I going to do to find its area? Good. So my base times my height would give me an area of what? 3. Good. Okay, I also need to find the area of the entire target. So I also am going to find the area of the total region. And how would I find its area? Good. So its area would be 40. Good. So if I asked you what the probability of hitting the shaded region is out of the entire target, you have a chance of 3 out of a total of 40, right? So the way you write that is P stands for probability, and then in parentheses, they'll tell you what it is you're looking for the probability of. So in this specific case, we said we were looking for the probability of hitting the shaded region. So in the top of our fraction, we put the number representing the shaded region, which we said the area of that was 3, out of the entire target, which we said had an area of 40. And we do always want to simplify if we can, okay? If we can't simplify, then we would just go ahead and turn this into a percentage. So 3 over 40 would simplify to what as a decimal? Yeah. So whenever we get our decimal, remember to turn it into a percentage, we just move it a couple decimal places, right? 2 decimal places. So I've got my 3 divided by 40. 3 divided by 40 should be 0.075, right? Okay, so if I move my decimal 2 places, that puts it right here, right? So that would give us 7.5%. Okay? All right, so anytime you are given one of these where you have a fraction, you always will simplify the fraction as much as you can, and then turn your answer into a percentage by finding its decimal value. All right? Okay, so now that we know the process, they give us a few different pieces down here saying using this definition, find the probability of landing on each color, find as a percentage to the nearest 10. So what we're doing here is we're saying if you throw a ball, theoretically, what's the percentage of it landing on those spots? So this is what we call theoretical probability. All right, so first they ask for red. This shape is going to be representing our red section. Okay, but before we can find what the probability of hitting the red piece is, we also need to find the area of the total graph, right? So I'm going to find the area of this entire graph. It is rectangular in shape, so just base times height, right? So what are the base and the height here? Good. So 18 times 13 gives us a total area of, good. Okay, so now that I have my total area, we are just looking to find the area of hitting red out of the total area. So I need to now find the area of the red. What kind of shape is that red figure? Parallelogram. Good. And what's our formula for area of a parallelogram? Okay. And what is the length of the base of this figure? 5. And what is its height? 5 as well. So the area of this parallelogram is what? 25. So the probability of hitting red is 25 out of how much? 234. All right, so it just asked this time for this given as a percentage. So I divide 25 by 234 and move my decimal 2 places. And what do we get? 10.7. There we go. All right. Next, they want probability of hitting green. This piece here in the middle is our green. All right, what kind of shape is this green piece? Good. And what's our formula for area of a kite? Remember, our rhombus and kites are the same. One half. Diagonal 1 times diagonal 2. All right. So what is the length of each one of those diagonals there? 6 and what? 6 and 10. So I got 1/2 times 6 times 10. So what's the area of this portion? 30. So the probability of hitting green is 30 out of, good. And what would that be as a percentage? Good. All right. Next, they ask for the probability of hitting blue. This piece here is our blue region. So what kind of shape is blue? Triangle. So area of a triangle. What's our formula for that? Good. All right, remember your base and your height have to be perpendicular to one another. None of these sides are for sure perpendicular to one another, so we need to pick 2 lines that we can say are for sure perpendicular. This line runs horizontally, right? So I could use that as my base. What's the length of the base there? 7. And this line is clearly perpendicular to it because it runs vertically, right? So I could say there's a 90-degree angle here. So what would the height be? 6. So we got 1/2 7 times 6. So what's the area? 21. So the probability of hitting blue is 21 out of that 234 total. Okay, so what would be the percentage of hitting blue? 9%, okay. Alright, then what's the probability of hitting yellow if yellow is this figure down here? Well, what kind of shape is yellow? Trapezoid. Okay, can somebody tell me what our formula for area of a trapezoid is? There we go. Alright, so what is the lengths of our base 1 and our base 2? Okay, so we got 1/2 times 8 plus 4 times, remember the height has to be perpendicular. What's my height? 5. Alright, so what do we get for the area of the trapezoid? 30. Alright, so the probability of hitting yellow would be 30 out of that total 234, which we already said that this would be what percent? Okay, which leaves us with the last portion to be this one. So this is the white portion they're referring to. Okay, so in that piece there, what kind of shape are we dealing with? A rhombus, right? The sides do look to be congruent. Okay, so area of a kite or rhombus, either way it's the same formula, right? What's our formula for that? Good. Alright, and what is the length of the diagonals of this figure? 8 and 4. So what is its area? So the likelihood of hitting white, or the probability of hitting white, is 16 out of the total 234, which is what percent? 6.8. Alright. So all you're going to be doing on today's assignment is finding the area of the shaded region. So there's going to be some shaded part inside of some other figure. And you need to put the area of the shaded over the total. And it says to simplify the fraction if you can and turn it into a percentage. Okay, so we'll be looking for two answers, the simplified fraction and the percent.